Dear students, in this class let us discuss about the relation between Mobius function and the Euler-Taussian function. So in previous class we were discussing about what is Euler-Taussian function and what is Mobius function. Mobius function is defined as mu of 1 equals 1, and if n is the product of distinct primes, if n is the product of distinct k primes, then phi of 1 equals minus 1 power k. If n has a square factor, then the Mobius function value should be 0. Also, the Taussian function is defined as that Euler-Taussian function, that is phi of n. Phi of n is nothing but the number of positive integers less than n and relatively prime to n. Now in this class let us discuss about what is the relation between this mu and phi. The relation between Mobius function and the Euler-Taussian function. How they are related. So they are related by, for any n greater than or equals 1, then phi of n equals sigma over d divides n mu of d into n by d. So this is the relation between phi and mu. Phi of n equals sigma over d divides n mu of d into n by d. How to prove this relation? This relation is proved by using the following arguments. We are starting from the definition of Euler-Taussian function. We know that what is phi of n? Phi of n equals sigma k ranges from 1 to n of 1. Okay. So this indicates there's a comma. That indicates the sum is extended over those k which are relatively primes to n. This symbol, that comma, indicates the sum is extended over this k, which is relatively primes to n. Okay. So it is we know that phi of n is sigma k ranges from 1 to n1, but it is same as this one is same as sigma k ranges from, that can be rewritten as sigma k ranges from 1 to n. It is greatest integer part of 1 by GCD of n and k. Why? There is no such confusion. Why? Because we know that this 1 by GCD of n and k means it is if n and k are relatively prime. If n and k are relatively prime, what happens here? If n and k are relatively prime, then the greatest integer part of 1 by GCD of n and k is 1 itself. Okay. If n and k are not relatively prime, if there exists any common factor other than 1 has this n and k, then 1 by greatest common divisor of n, the greatest integer of 1 by GCD of n and k should be 0. Okay, that is because of the property of this greatest common divisor. So that this 1 can be expressed as in this way. Sigma k ranges from 1 to n, 1 by, so the greatest integer part of 1 by GCD of n and k. Clear? Okay. What is this k? The k runs through every integer less than or equals n. We also know that what is mu of d, but we know that the Mobius function mu of d equals sigma over d divides, or sigma, yes, we have sigma over d divides n mu of d equals greatest integer 1 by n. This is a well-known result, this is already proved. Okay. Sigma over d divides n mu of d equals greatest integer 1 by n. So this means, how to relate these two? So this becomes sigma over D divides, instead of n, suppose it is GCD of n and k of mu of D is nothing but greatest common divisor of GCD of, 1 by GCD of n and k. Clear? Listen, sigma over D divides n, mu of D is greatest integer 1 by n. This is a well-known result. So, from the light of this argument, we know that sigma over D divides GCD of n and k of mu of D is nothing but greatest integer part of 1 by GCD of n and k. Okay. Therefore, what is phi of n? Therefore, phi of n equals, but we have phi of n equals sigma, this one. Come to this argument. Phi of n equals sigma or k ranges from 1 to n, greatest integer 1 by GCD of n and k. So from there, what is phi of n? Phi of n equals, it is sigma k ranges from 1 to n. What is greatest integer 1 by GCD of n and k, which is nothing but this one. So it is sigma k ranges from 1 to n into sigma d divides GCD of n and k of mu of. Agreed? From these two results. From these two, we have phi of n equals this one also, but this sigma d divides GCD of n and k of mu of d is this one. So by combining these two, we have phi of n equals, instead of the greatest integer 1 by GCD of n and k is replaced by sigma over d divides GCD of n and k of mu of d. Agreed? So phi of n is this one. Clear? That means this can be again rearranged as phi of n equals sigma k ranges from 1 to n, sigma over d divides GCD of n and k means sigma d divides n and d divides k of mu of d. Okay. So, for a fixed divisor d of n, we must sum over all those k in the range, k ranges from 1 to n, which are the multiple of d. Okay, here what is d divides k? D divides k means what is k? K equals q into d. Agreed? K equals q into d, where this k ranges from where to where? K ranges from 1 to n. K ranges from 1 to n, therefore this means this 1 less than or equals k by d less than or equals n by d. Okay, what is k by d? That is q. That means 1 less than or equals q less than or equals n by d. Clear? Hence, this sum phi of n equals sigma k ranges from 1 to n, sigma over d divides n, d divides k, mu of d can be rewritten as, this is nothing but sigma over d divides n, and when d divides k equals q of d, where q ranges from where to where? 1 to n by d. So it is sigma over q ranges from 1 to n by d mu of d. Okay. For u of n equals this one. But we know that d divides k means k equals q into d. Moreover, this q ranges from where to where? 1 to n by d. Why? Because k ranges from 1 to n. 1 less than or equals k by d less than or equals n by d. 1 less than or equals q less than or equals n by d. So it is q ranges from where to where? Instead of d divides k, this can be rearranged as sigma over d divides n, sigma q ranges from 1 to n by d of mu of d. Okay. That means this is nothing but sigma over d divides n mu of d into sigma q ranges from 1 to n by d of 1. Clear? Okay. That equals sigma over d divides n mu of d into, what is this one? Sigma q ranges from 1 to n by d of 1. That is simply, it is n by d. Clear? Sigma q ranges from 1 to n by d, sigma q ranges from 1 to k of 1 is k itself. So sigma q ranges from 1 to n by d of 1 is nothing but it is n by d. So finally, phi of n equals sigma over d divides n mu of d into n by d. That is what we require here. Okay, so this is the relation between the Mobius and the Euler-Torsion function. Clear? If mu of n be the Mobius function and phi of n be the Euler-Torsion function, then for every n greater than or equals 1, we have phi of n equals sigma over d divides n mu of d into n by d. So this is the proof of that relation. This relation is important. How to relate this Mobius and Euler-Torsion function? They are related by using these arguments. Okay. So this arguments this is heavily depends upon the definition of the Euler-Torsion function. We are starting from here. Phi of n equals this one, but this one is nothing but greatest integer 1 by GCD of n and k. Why? Because of this argument. When GCD of n and k is 1, this is nothing but 1 itself. Otherwise, it should be 0. Okay. But we know that sigma d divides n mu of d is greatest integer 1 by n. So when you replace n by GCD of n and k, this can be replaced by this way. Then you can supply phi of n equals, supplies the value of this one here. Then we know that sigma d divides GCD of n and k means it's d divides n and d divides k. But d divides k means k equals q of d. Finally, q ranges from 1 to n by d. So this sum can be rearranged as in this way. Sigma over d divides n. Sigma q ranges from d instead of d divides k. It is sigma q ranges from 1 to n by d of mu of d. That is rearranged as sigma over d divides n mu of d into this one. We know that this is nothing but n by d. So that is the complete of this proof. Clear?